In this video, I'm going to try to explain classes, and I figured the best way to probably do that would be to look at a game engine, because that way you can visually kind of see what classes, kind of like a way you can use classes, so kind of what they are. So normally I try to describe classes as a box. So let's say you have this box. Inside the box, you can have variables that only things inside the box can access. And then as well as you can, on the top of the lid, you can add public things that other people can access. So it's just a box filled with contents, information, functions, and that kind of stuff that you can take, move, copy, kind of anywhere you want. So looking at it in terms of game development, this character right here, well, this character is a class. These arms, these are a different class. This camera, that's another class. This cube, that's one of my classes. And this cube, this is a different class. This light and everything, the spawn point, all these are all classes. Now, you can do a lot of things with them. One thing I want to talk about is inheritance, which I will kind of reference here in a minute once we actually jump into Visual Studio and dive into classes just kind of right away. So let's go ahead and do that. I'm going to go ahead and create a character class because I figured this will be a good point of reference. So what I want to do is I want to go ahead and do class a character because I'm going to follow along with the same kind of naming scheme as Unreal Engine. And there is technically right there alone, that's our class. We can use it by doing a character just like we do with a normal variable and calling it character. And now we have access to our character, but we have nothing inside of it. So what are some things that we can put inside? Well, first thing being we can put some variables. So inside of classes, and same thing with structs, you can kind of set these accessors. So I look at them as kind of like sections. Like public would be what is on top of the box that other people can access. Private, that would be stuff that you would want inside the box that only things inside of the box can access. As well as there's protected, and protected I will get into when we actually go into inheritance again. So we're going to start out with public. So public is stuff anyone can access. What's an example of that? So let's say we have our character. So we want on our character to have a variable called health. So we're going to do int health. So now when I go to our character, I press dot, we have this variable called health. So we can even print that out. So std cout health character health. Just a couple new lines. So let's go ahead and just set that to a default value of 100. Run it, and we should see 100 getting printed out, which we do. Now, instead of defining everything like this, you can also do what's called a constructor. So you have these instructs as well. So pretty much like a character, you would do the name of the class and then treat it as a normal function. So in here we could do health equals 100 and remove it from the declaration right there. And when we run it this time, it's going to also say 100 because the constructor, whenever we create the class, so right here on line 16, that is going to cause this part to run. It's going to trigger the constructor. Now, there's also destructors, which we will get into later, but that's not really the focus. But whenever the class is kind of destroyed, so to speak, the destructor will run. So it's the opposite of the constructor. So instead of, you can kind of think to yourself, well, what if I have a bunch of functions? Well, better yet, let's cover private real quick. We'll do that first, and then we'll move over to that section. So let's say we make our health variable private. Well, now we no longer have access to it. You can still access it from inside the character just fine because it's whatever's inside the box, and dang it, people are being loud here, go figure. But we can't access it from outside the box. What we can do is what commonly is referred to getters and setters. So in this case, we want to create a getter to get the health value. So what we can do is we can make a function to return an int get health, and it's just going to return health. So now we can do character dot get health, and that will return 100. just like so. That's kind of how that takes care of that. And you would do the same thing for set health. So void set health, and you would just do health equals, well, let's pass in a parameter, new health, health equals, ooh, that formatted kind of weird, health equals new health. Now we can do character dot set health. We're going to pass in 250 or 240, typo. Now health, when we print it out, is 240 because we are setting it. Now you can kind of think to yourself, what if I had a bunch of these functions that are really long? Wouldn't this kind of clutter it up? And it really would. It would look pretty terrible. I don't even know why this is complaining, but one thing we can do is we can create a dedicated .h and a .cpp for our class. So we're going to create these in a separate file and create the definitions of the functions in a separate file as well. So it's going to keep it a lot cleaner. So we're going to go to our header. We're just going to right click, add a class. Class name is a character. Press OK. And go figure, you're going to complain. So let's do old character just for the time being. And see if it lets us this time. Okay. It's creating our a character class. Now we can copy these contents, paste them right in, delete this old class, and rename this back to a character. Now the only thing we have to do is, as it's stating, we have to include our character class. So we're going to include a character. Here we have it. We are good to go. What are you complaining about now? Constructor. Oh, right. Oh, we have to go ahead and make the constructor itself public, so that way it'll quit complaining, because the constructors and destructors are always public. So now when we run it, we get the exact same result. Except we now have our header in a separate file that we can just include like this. Now instead of cluttering up our class with a bunch of functions, we can use this .cpp that got generated for us as well. So what we do is we go ahead, and I can just leave these, add semicolons to the end so they're just the declaration, and I can go ahead and generate the implementation of each function. And as you can tell, it automatically puts them inside of the .cpp, that is including the character.h. So we're going off the class, and then we have our function to define it. So here we just return health, and here we just set health. So health equals new health. So now when I run it, we're still at 240. So it's all working the exact same, except we have this nice clean health class, which we can also do for the constructor. So we're going to do this constructor the same way as a function, like that. And now this is the only thing inside our health class. We just have our constructor declaration, our health, get health, and set health. And everything that we do to control these variables is inside of our .cpp. So now when we run it, we get the same result of 240, except now we have a much cleaner character class. Now let's move on to inheritance. So this character class, let me actually pull it up on Google real quick. So it's Unreal Engine a character. Once it actually loads. So if we look at it, we can see the parents of it. So here's a character. Well, it's derived from a pawn, which is derived from a actor, which is derived from uObject, which is derived from uObject base utility, which is derived from uObject base. So there's many layers here. So there's obviously a lot of stuff that gets overridden. So for example, we might want to define something that is inside of, let's say a actor that we can use in a character, which is the case commonly. So inside of a actor, so in this case, actors are things in the world. So everything you see is an actor. We look for, what is it, location? No, it's get actor location. We can see here we have get actor location inside of our A actor class. Well, when we come over to a character and we search for get actor location, we won't find it. But in reality, if I were to go into like Visual Studio inside of this project here, we could access get actor location from a character. And the reason for that is because they are overriding functions. So they're inheriting functions. So we're going to do that. We're going to change this class from a character to a actor, just following kind of alongside the same thing. Like so. Let's go ahead and actually rename this to a actor, and a actor.h. Now we include a actor. Well, this is all going to work the same. However, I want to do one thing. I want to create a class called a character that uses a actor as its parent. So what I'm going to do is I'm just going to create a new class, just like last time. Let's call it a character. And then with the base class, it's going to be a actor. And press OK. Now let's load it up. And we don't see anything, but we would define it the exact same way. So we have class. I really don't know why it didn't actually set it up for us. But we have class a character. Why can I not press enter? Really? Okay, that's an interesting one. I'm going to go ahead and include a character.h. Okay, I cannot press enter. Let me try to see why real quick. Alrighty, so I just closed it and reopened it, and it spammed all my enters. But anyways, we do a character, and here we just have a normal class. So for the time being, we're just going to include a character and make sure that's set to a character. Now, as you can see, we no longer have the health or anything, and that's because it's stored in our a actor class. So we want to inherit all of this information into our character. So we're going to inherit it by doing a colon, public, then our class name that we're inheriting from, which is a actor, and in what case we have to include our actor. So now when we head over to it, we look at it, everything's okay, we try to run it, and we print out 240. Now you'll want to notice something. When I go to my aactor.cpp, I can access health just fine. But let's say I want to do something here. I want to do public. Well, let's do a void multiply health int value. Create the implementation, and let's try to use health. So health times equals value. Well, look at that. We can't access health. So that's where I was bringing up the protected section. So because it's private, it's only going to be known to a actor. Now, it's not any class that inherits from it, a actor like this, like our a character class, we cannot access health. So what we would have to do is make health protected. So that way it's still private, so I can't access it directly, like I can't do character.health. It's not going to come up like it would if it was public, but I can access it through our inherited classes. You can also do this with friend, which will kind of do the same thing. So you can friend it. I don't remember the syntax for it. It was like friend. A crap. I can't remember what the syntax was to make it a friend. But if you Google it, it'll come right up, I'm sure. But that allows us to use health inside of our child classes that inherit from a actor. So just like our get actor location, well, that was defined or declared and defined inside of a actor, but we can use it inside of a character or a pawn or any class that derives from a actor. We can use that function. So this allows us to now as well, we're going to change this. We can use set health, we can use get health, and we can use multiply health, which I'm just going to pass 2 in. So I'm going to double it to 200. Like so. So we now have access to get health, set health, and multiply health. Now, if you wanted to, you can also do your own constructor as well. So a character, we can do health equals, let's do 200. So now when we run it, it should be 400, like so. So we're kind of replacing this constructor with this constructor. Now let's say we have, let's see, well, I'm trying to think of what would be a good function name. Let's create a new one. So in our actor, we're going to do int get a number. Yeah, that's okay. And did not mean to rename. Let's just make it return 5. So that's all it's going to do. Let's do the same thing over here. Let's just call it, so we'll get rid of our health stuff, and we're just going to do character dot get a number. So it's going to return 5. Great. Now let's say we wanted a actor to return 5, but we wanted a character to return 7. So we want it to return a different value. Well, we can do what's called overwriting. So in this case, it's not going to work, but we're going to do int get a number, and we're going to return, no, let's do, what did I say, 7? We're going to return 7. Well, let's try running it. Return 7. However, what we can do, so we don't have duplicates, did I spell that the same? Yeah. So we don't have duplicates, is we can do what's called function overwriting. So I was wrong. This actually is going to be fine. So what we could do to check that, or as you recall, when I was typing in int get a number, nothing comes up for IntelliSense. But if I make get a number a virtual function in our actor class, and then do virtual int get a number, you can see it comes right up, and we can override it. So we're not necessarily defining a new function, where you can kind of think of it as you're replacing a function. So now we are overriding get a number to return 7, like so. And that actually made me kind of curious. I've never tried to call the base, so I wonder if return get a number, I don't know. So that allows us to return 7. So that way we can inherit from a actor and override some of the functions, which that is something you would do, for example, in Unreal Engine quite a lot. So that is, for the most part, going to be kind of everything. Not really much else to add, but yeah, that covers the gist of classes. So we have defining, variables, constructor, functions, inheritance, public, protected, private, overriding. I think that's pretty much it, at least off the top of my head. So hopefully you learned something. And yeah, that's about it. If you like what I'm doing and you want to help support me, you can find a link to my Patreon down in the description below, where I have a Team Deathmatch series tutorial where we create Team Deathmatch in C++ using Unreal Engine. And if you have any questions or anything like that, feel free to hop in my Discord and ask away, and I'll try to answer answer them to the best of my ability. And as always, I will see you in the next video.